like I don't have enough memory or something. Well, let me see what happens as I go. So here we go. What week is it? Fifth week already? Is that right? Fifth week of school? I think it's the fifth week of school. We only have, we're a third of the way through. It's really a 14-week semester, but there is kind of 1 week that's cut off with Thanksgiving. So I call that the 15th week, and then the final exams is the 16th week, right? So I mean, direct weeks. So even though, we'll be at home for Thanksgiving break, I'm still counting that as a week, just to keep the counting simple. Not that it matters anyway. We should have our next test in probably 3 weeks. So what is today? The third or fourth? Today's the third. Is that right? Yep. So 10-3, Wednesday 10-5, Friday 10-7. So I'm thinking the 21st will be our second exam, Chapter 3 exam. Calvin, question? No? So I should have time for at least another quiz. Let me just put it on the 14th. Let's not do a quiz this week. Let's put it on the 14th. Just because I'm a little overwhelmed. I think you might be overwhelmed. But it will include product rule, quotient rule, trig derivatives, and chain rule. Right? The next quiz will contain all 4 topics. Yep. Say again? Say again, David? Quiz. Yeah. So we'll do a product rule, quotient rule, a chain rule problem, trig derivative, right? Tangent line, that kind of thing. Yeah, a lot of you are giving me cos of minus pi over 3, or it's not probably a good idea. Let's say it's cos of minus pi over 6. You're giving me like 0.866, right? Which is, I mean, if I go to the calculator, it's true, but it's not what I want to see. I want you to know the trigs, right? You should know that that's square root of 3 over 2. So some of you need to work on that trig stuff. I don't want you missing classes. And I know if you're sick, right? But it helps to not miss a class, because I'm going to do chain rule today, and students that miss the class are going to go, what the hell's going on? So it really helps to not miss class. Morning, Max, I have your test. Once a few more people come in, Max, I'll give my whole spiel on how you can have anyone express that you agree. It's kind of like you're learning how to be a student. For me, high school, I know, was studied nothing and I passed. So you've got to learn how to get into it and become a good student. It's a lot of work, okay? It will pay off. You won't remember the pain. Nice. Oh, I'm recording all of that. So anyway, not this Friday, but Friday the 14th, almost bad luck, we'll do another set of 4 quizzes, right? So make sure you're practicing product rule, quotient rule, trig derivatives, all with tangent lines, and the chain rule. The chain rule is the big one. It's the difficult one. So here we go. We're going to talk about the chain rule today. I'm pretty sure I only have 3, 4, 3, 5, 3, 6, 3, 7. I only have 4 sections to teach in chapter 3. So definitely we'll be done Monday. We'll be done with chapter 3 Monday. And then I start chapter 4 with the intent of not screwing you up. Meaning, I'm going to pick sections of chapter 4 that shouldn't bother you, because we'll just be doing what we're going to be doing, something called first derivative test, second derivative test. So it shouldn't bother you too much. I've been doing it for, do it. 4 questions. Yeah, 4 questions. Yep. So 4 questions, 8 minutes each, right? 32 minutes, so we'll start around 10 of, what do we start at 9? So we'll start around 10 of 10 or so, right? Good morning. I'm sorry, you didn't take it. Lana, sorry. And so I was just saying, if some reason you didn't take the test or you bombed the test, I will replace the lowest test grade with your final exam grade. As long as it's bigger, right? I'm not going to replace it if it's lower, right? Make sure you play a crime scene also, CSI math version. You go back to the old tests and you see that there was something like the questions on your exam, like they were on the old exam, and then prepare for the chapter 3 test. That Autumn question? No? Okay. All right, sorry. I got a lot of dead air recorded there, but that's okay. We're talking about the chain rule today. So if I have y equals f composed of g of x, composition of functions, we've already done that this semester, right? Where have we done a composition of functions? Where have we put another function inside of a function? Where? No, in this class, right? No. The limit, the derivative has a limit. What are we plugging in for? X plus h, that's a composition of functions, right? So we're talking about how do you take the derivative of a composition of functions. And it turns out that it's the derivative of the outside evaluated at the inside times the derivative of the inside. This is the chain rule. And I'm going to teach it a couple of ways, and you can pick the one that you like the most. For me, it's inside-outside thoughts. That's easiest. So you see here, this is my outside function, right? Prime, evaluated at the inside function, and then multiply by the inside prime. So the trick, I guess, is to be able to recognize inside and outside functions. Like if I gave you this function, right? It's pretty easy to see that the outside function is square root, right? And we know how to take that derivative. And the inside function is a quadratic. And we know how to take that derivative, right? So, but the tricky part is to know what's inside and what's outside. That's the toughest part of this. I will also teach it to you with a loop. So you will see it with a loop as well. So this is one that's tricky. What's the outside function here? What is it? Sine squared only.
Okay.
Square, not the square, you said square root? Not sine square, you said sine square. Yeah, not sine square. No, that's actually, that's the inside function. Sine of 2x. Outside function is something squared. X squared. Right? So, how do you know how to take a derivative of x squared? Hell yeah, 2x, right? Then you're going to put the inside function in, and then use the derivative of the inside function. What's the derivative of the sine? Okay, so see how complicated it gets. It's pretty complicated right away. Yes, sir. It was saying cosine of 2x. So this is actually a nested chain rule. There's an inside of sine of 2x, and inside of that, there's an inside of 2x. So we're not doing it yet. We're just saying, just want to see if can we recognize the inside or the outside, right? Sometimes they're just tricky. Sometimes they're just tricky because you might not know the function that well. What's this outside function? E to the x. And what's that derivative? E to the x. And then our inside function is cosine. So we eventually have to multiply by negative sine of x, derivative of the inside. I will teach these all inside, outside, and with a loop. So if you like the loop for product rule, quotient rule, the loop for the chain rule is very similar, okay? So I want to talk about this in general before we do a problem. And then we're going to do a problem like we did before, where we needed the chain rule and where we didn't need the chain rule. The new rule, though, is you need the chain rule all the time. You only need the product rule when you have a product. You only need the quotient rule when you have a quotient. But you will always, for the rest of your mathematical careers, use the chain rule, okay? Hey. Morning. I was at Caldy this morning grading, and I spilled coffee on your test. That's why part of it's ripped off. Okay, so let's talk about the theory first of all. And what I do is I put a cat in a box. So don't make fun of my cat, please, but you know, whatever. I don't care if you make fun of it. So I'm going to put a cat in a box. And I'm gonna push it down a hill. Hey, welcome back. You feel all right? Oh, Michael, wait. Not that I hate cats. I'm more of a dog person, but so I'm going to take this box and I'm going to, let's say it's icy out or whatever. I'm going to start pushing it down a hill. Now it's changing. Just do you agree? So we're talking about the derivative is distance, time. It's a slope, right? So the box is sitting still. That's y equal. But when I start moving the box, right, that is how it's changing, right? So I want to think about it, right? I want to think about it in terms of how it's changing. So we'll say y prime is the derivative of the box, how the box is changing, right? So prime on that. But the cat is still in the box. What was in the box originally stays in the box, right? So the derivative of the box with the cat inside of it, right? So the cat's still in there. But couldn't the cat be freaking out and like jumping all around? And that's also changing the box, right? So that's what you're thinking about, the derivative. How is the inside also changing that could affect how the whole thing is changing? Right? So cat prime. So derivative of the outside. Keep the cat in the box. Hey, how you feeling? Better? Nice. Thanks for the homework. Here. Oh no, I'm going to get you a copy of the test, and I'll talk about it again. So how the box is changing with the cat still in the box, and then how the cat is changing. So I might have a cat that just ain't a mouse inside the box, right? So the cat is getting energy from the food, and the mouse is also changing. So that I would need to multiply by how the mouse is changing, right? I would keep the mouse, right? That's a nested one. Is that making sense at all? The hard part is recognizing when you have an inside function and an outside function. So let's do one. Let's do one real simple, right? Let's do that first one we had, square root of x squared plus 3x. I don't remember what I had, but it's close enough. So we know that the outside function is 1 over 2 square roots, right, when I do the derivative. But I want to keep what's in the box in the box. So I'm going to do x squared plus 3x plus 1. And then I'm going to do the derivative of that, right? So what is that? 2x plus 3 over 2 square roots of x squared plus 3x plus 1. So there it is. There's our first chain rule. Hard part is seeing what's the inside and what's the outside. This one's very easy, yeah.
Okay.
Yeah. So there, the outside is clearly square root, right? Yes, David. Yeah. So I took the derivative of the square root function, and I got 1 over 2 square roots. I kept what was in the box, still inside. But then I have to make sure I take the derivative of the inside. And what's the derivative of x squared? There you go. What's the derivative of 3x? There it is. 2x plus 3.
Okay, so in this time like
Yeah, so I'm multiplying by the derivative of the inside, right? Here's the derivative of the outside, multiplying by the derivative of the inside.
okay.
Yeah, I just put it into the numerator, exactly.
Okay.
Nice. Yes,
But you can't see the question.
I can't really. I can't cancel these twos because this 2 is involved in a sum. It has to be a product only before I can simplify. Right? I have to be able to factor a 2 out first before I could change that. And I could factor the 2 out. It's stupid. What do I get? X plus what? Yeah, x plus 3 halves. And now those 2's could cancel, but it seems kind of dumb to me. And this is what my teacher would say. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. One extra stroke, now that I've simplified it, doesn't make it simpler, right? And that's me talking from a computer science aspect of it. But same if I'm doing a bio report, if I'm doing a write-up for my company, it's got to be concise, right? You don't want extra things in there. Let's look at that same one with the loop, okay? So what I like to do is put my outside function here, which was square root of x, right? Just the square root function. And then I know the derivative is 1 over 2 square roots, right? The inside function was x squared plus 3x plus 1, and that derivative is my 2x plus 3, and my loop is coming from here. I want to put g into the x placeholder, right? All of this is going into the x. Keep keep the cat in the box, and then multiply by this, right? So y prime is 1 over 2 square roots of that times 2x plus 3. And of course I get there too, but it's just, I'm trying to show that, you see inside the loop, that's what's going inside the first derivative, the derivative of that outside function. Exactly. Yeah. Question.
Why all that is, it's still in square root, because isn't it, f prime of g doesn't have square root, like?
Fine, you can think of it that way, that's good. That's a little bit more sophisticated. I'm trying to make it as simple as I can. I just want to think of the outside function. I want to think of our shortcut derivative. I want to think of the inside function. It's shortcut.
That's why, it's 1 over 2 square root, it's not
Exactly.
just 1 over 2. I missed that for the
Yes.
square root part, that's fine.
Yep, see it? So why did I loop around it? Because it's inside. I want that piece inside here.
I missed for the x what's in the, for,
Exactly.
f prime.
Exactly.
Right.
Okay.
Yes. So either way, and I will do, as I do problems today, I will do some inside outside and some with the loop. I personally think inside outside is the easiest way to go. We had one on our test that I asked you to do. I think it was y equals -4 times square roots of 5 minus x, I think, right? So I asked you to do that with a limit, but now we could do it with the chain rule. What's the outside function? Square root, right? So the -4 I don't care about, but I do know I'm going to get 2 square roots, but I want to keep what's in the box. So that's a 5 minus x, right? And now the derivative of the inside, what is it? -1. So the double negative, we get 2 over square roots of 5 minus x. So the chain rule is going to apply always. You will always use the chain rule. Okay, from now on. In fact, you will realize that we've been doing the chain rule the whole time. We've been doing the chain rule. If y equals sine of x, what's the outside function? Sine. Outside the sine, right? Sine of parentheses x. Yes. What's the inside function? X. What's the derivative of the inside function? I've made sure that every problem you had an inside derivative of 1. And so we were secretly doing the chain rule, but there's no point in saying, well, and then multiply by 1. Right? Because it doesn't do anything. It doesn't change it. So we've been doing the chain rule the whole time. But what we're really looking for now are complicated insides. We're looking for complicated insides. Inside functions that don't have a derivative of 1. Right? And that's when we really know we have to do the chain rule. Yeah, so do you agree with the black here? Like the square root function. I kept the 4, right? The coefficients just go for the right. And I got 2 square roots, but I kept what was inside, 5 minus x. Then what's the derivative of 5 minus x? -1. Right? There's a slope of -1 before that x, right? And so 4 over 2. Yep. David, yes? Okay, but the 4, you okay with the 4 goes along to the right?
Yeah.
Okay. So and you okay with the inside derivative is -1? Yeah. Okay. 4 times -1 is 4. 4 over 2 is 2. Right? So, like, you'll look at my midterm exams from last 3 or 4 semesters, and you'll see me ask, hey, do this with a limit, and then verify with the chain rule, right? And it's not completely out of reach for me to do that on this test coming up. right? And by the way, our next test is on 10/21, Friday the 21st. So this Friday, we're not going to quiz, but next Friday we will quiz. Try to keep it to 8 minutes a problem. I think that's fair. We had 8.5 on the test, right? So we'll try and keep it like that all semester. And yes, some of you need to speed up. But you'll get it. With practice, you'll get it. Okay, let's try a couple with and without. So, meaning I don't have to use the chain rule if I can manipulate it, and I will have to use the chain rule if I can't. So let's do y equals e to the 2x. Pretty clear, the outside is the function e to the x, and the inside function is 2x. Nice. So, but this one, I can manipulate. This is e to the x plus x, which is e to the x times e to the x, right? When you're multiplying like bases, you add the exponents, right? X plus x is 2x. So on this one, I can do it without using what rule? Product rule, yeah. So first function is e to the x, derivative is e to the x. Second function in the product is e to the x, and its derivative is again e to the x. And I'm doing this product loop. So it looks like I get y prime is e to the x times e to the x plus e to the x times e to the x, right? So it's two of them, right? I got two of the same thing, yes? But I have 2 e to the 2x's. And there's my derivative. We okay here? Calissa, yeah? Okay. Yep. Max? Yes, Abigail. Okay, beautiful. That's what we're doing next. So that was without, now with, right? Y equals e to the x. I know the e to the 2x. I know the outside derivative is still e to the whatever was inside times the derivative of what's inside. That's the derivative of 2x, which is just 2. So there it is, 2 e to the 2x. Easier with the chain rule. Easier with the chain rule than doing the whole product rule. And so that's what we're going to keep doing. All through Calc 1, we're going to learn these new methods on how to take derivatives, right? Until they start to fail. Until I can't take a derivative of something. And that part is saved for Calc 2. Then in Calc 2, we learn how to undo derivatives until it fails, until I can't do anything else. And then we turn everything into sequences of series. And that's what it gets done. Right. Let's do another one with and without chain rule. We okay here? I mean, I may have talked it up a little bit too much that it was difficult, but you have to get in there and practice. That's the thing. All right, so let's do another with and without. So y equals sine 2x. Clearly, the outside function is sine, and the derivative of the outside is cosine. But what do I need inside still? 2x. Keep the cat in the box. Whatever was inside stays inside. But then multiply now by, derivative of the inside, which is 2. So we get 2 cos of 2x. Now that was with. What about without? How can I rewrite this function, this trig? You recognize this trig identity? What is it? It's 2 sine x cos x. Right? Do we remember that? Sine 2 theta is 2 sine theta cos theta. And now we're going to use a product rule, right? First function is 2 sine x. What's the derivative? 2 cos x, right? Right? Second function is cos x. What's the derivative? Negative sine x. And we want this loop. So it looks like we get, for y prime here, we get 2 cos squared x minus 2 sine squared x. If I factor out that 2, I recognize another trig identity, and we want to make sure we have all these trig identities on our formula sheet. This one is what? Cos of what? Yep. One more with and without. Question? Sheila? It's not one. It's cos squared plus sine squared. That's how I remember that it's the minus in between, because it's the plus in between is 1. So for the cos of double angle, I'm always trying to remember that we need the negative in there. Yeah. Talk. Where are we? Yeah. So this product plus this product. When I do the product rule, I can do any diagonal first. Oh, over here. Yeah. Okay. So we're talking about y is sine, outside is sine. What's the derivative of a sine function? A cosine function. Keep what's in the box, and then what's the derivative of the inside? Let's do another. With and without, okay? This is the tough one, and this is the one I always put on with a tangent line. So if y equals sine squared x, right? So this is just sine x, right? So I could do product rule, clearly, right? But let's see if we can do it with the chain rule first. I'll start with my loop. My original function is a square function, x squared. What's the derivative of that? 2x. What is inside is sine of x, and what derivative do I get from sine of x? I get a cos of x. So I want to take the 2x, compose it with sine x, and then multiply by cos x. So y prime here is 2 sine x times cos x, which of course is what? Sine 2x, right? 2 sine theta cos theta is sine 2 theta. So these little trig things start to show up quite a bit. Right? Yes. That's good. Okay, it's not times, it's put it inside, right? This is now the box, it's a placeholder. And I'm saying keep what was inside, right? It's not easy to see this one. It takes a couple of glances and some deeper thought. But the original function is sine squared, but it's a square function, right? And our derivative of a square function is 2x. But the original cat was a sine of x. So keep the cat in the box. See 2 times x there? Right, but I'm filling it in with what was originally in there, and then multiplying by the derivative. Yes. Yes. And this is a composition of functions. I don't know if you saw it on the news today, but they realized that Beethoven had some pieces of music buried with it that no one ever heard. They dug up the tomb, and Beethoven sitting there erasing. And they said, "What are you doing?" He said, "I'm composing." Isn't that funny?
I
get it.
I mean, it's not.
Thank you, I appreciate